let's go. Today, we'll spend like probably 10-20 minutes together. We'll speak about serverless and global deployments across both CPU, GPUs, and accelerator. And we'll dive into how we leverage Vultr's global infrastructure to actually deploy workloads for our end users. So to give you some background, I'm Jan. I'm the co-founder and CEO of a company called Koyeb. I spent the last 14 years building cloud infrastructure, mostly here in Europe. So if you're local, you might know the two first companies, Outscale and Scaleway. I did this for 10 years with these two companies. We were building IaaS cloud infrastructure. And since 2021, we're building Koyeb, which is a global serverless platform, and we are providing basically serverless cloud infrastructure. So one of the key elements we're focusing on at Koyeb is basically efficiency. And we are starting from the fact that AI requires massive cloud infrastructure. So if you look at the numbers, AI represents today 28% of the data center IT power used in the US. So it's already 1/3 of the power which is consumed in the US. And it's actually just the beginning. So knowing this, basically, we also saw that in the next coming 4 years, there is going to be a 500% increase in the US data center power capacity used. So it's going to basically be multiplied by 6 over this next 4 years. So it's really just the beginning. And we see two key changes when we talk to our customers and end users. One is that AI infrastructure deployments are completely inefficient. So most of the time, infrastructure is underused due to lack of capable software. And there is a simple reason for this. Previously, technologies to increase usage were designed to share a CPU and a piece of hardware, and to increase the way it's shared by slicing it up. The thing is, with GPUs and accelerators, what you want is actually the full power of the GPU or of the accelerator when you do your processing, because that's why you actually initially use a GPU or an accelerator. And so the software which was designed before is completely inefficient for this kind of workload. So that's one challenge. And on the other side, and it's related, teams suffer from complexity and cost. So 75% of organizations lack cloud resources and or expertise. So we're working on both of these angles. And we believe that AI workload needs serverless capabilities to increase efficiency. So we see it as a full cycle. 20 years ago, people were mostly focused on racking and deploying hardware, and over time, the way workloads started to be deployed evolved. So then you saw VMs, IaaS with AWS, which came to market, or even Vultr, who actually started as an IaaS player and then evolved in upper layers. And then Kubernetes came, and we believe the next wave of infrastructure is actually serverless, where you don't have to deal with orchestration. So it doesn't necessarily mean function when we speak about serverless. It's actually about providing an experience where you don't need to deal with orchestration, auto-scaling, auto-healing of containers, and it applies to both containers, function, and databases. So our products at Koyeb is that we provide a high-performance serverless platform. So that's what we built. We let you deploy model and agents with continuous deployment. Behind the scene, it's always containers. And we do this on top of high-performance hardware, which can be Vultr's hardware or a different kind of hardware. We are mostly focused on the software side. And we provide an experience where you don't have to deal with infrastructure management. And one of the key things is to provide you with native resiliency and scalability of the workload. So what we actually let you do is we let you deploy serverless containers for high-performance inference and APIs. and I'll show you in a bit like how it actually works. So technically, this is the stacks that we have. So it's containers which are running inside of VMs for security and isolation on top of virtual machines. So we operate at the bottom. We operate on different providers, including Vultr or other third party. In some cases, we even rack our hardware. And at the top of this, we operate our own network layer and virtualization layer for security. And your workload is going to be deployed inside of container, inside of this VMs. And so you can deploy both like agentic workloads, more traditional APIs, and inference engines, which you see on the right of this slide. So we leverage actually Vultr's footprints. Vultr has 32 global locations with CPU, GPUs, and accelerators. So we're able to deploy across all of these locations. And we provide a consistent experience across any of these locations with the same interface. As I mentioned, like it's a completely unified and global experience which is using our software technology and Vultr's technology infrastructure below. So let's dive into how it works actually. What we are going to do right now is we are going to deploy an auto-scaling serverless inference endpoint of Flux 1, which is a generative image generation model. And this model is going to be optimized with Puna AI. And we are going to deploy it live together in one click, and we'll test auto-scaling capabilities, which are where our workload is going to adapt to demand. All right, so what I have here, so let's start by deploying maybe a new Flux model with Puna. So if I go here, I search for Puna. It seems like the latency is not like, might be a bit slow. Okay, that's like, as expected, it's like the network is a bit slow. Right. So here we have Puna. Where is Puna? It's actually in models. That's why. It's actually in models. So that's actually our catalog of one-click deployment options. And if network is with me, that's further again. So if I go here, Puna. Okay, so here we have Puna, and it seems like the network is extremely laggy. So yeah, that's interesting. Seems like we do have some network, but it's not like working like crazy. So not sure what's happening exactly. If it's like our website. Yeah, it seems like there is some network. So that's interesting. Anyway, okay, so we'll go directly to the control panel here. That might be easier. Yeah. Yeah, but there is something again with network. And basically what I'm trying to show you right now is we have like this one-click deployment options, and I think it is network, so I'm going to try to tether quickly because I do have 5G. Okay, we can try this one, but it's like it's weird because it seems to be relatively stable. And it was working just before, as always. Is it my laptop or? Okay, all right, so, yeah, and, oh yeah, that's way better. So we're back on track, and basically what we have here is like this Puna AI model. We are going to deploy it together. If I hit deploy, we're going to land on the on our control panel where we can actually like choose which GPU we want to run it on. So we're going to be running it on like an Elephant ES, and we are going to hit deploy, and basically we are going to get like this model deployed in about like 1 minute, running on a dedicated instance. And so what I want to show you today is actually then like once you have a Pruna model deployed, we provide auto-scaling capabilities. So we'll be testing together actually. So here I have both the model deployed and a front end deployed. So the front end is here, and we can actually do some generation of our model. So because we're with Vultr today, we are going to actually generate maybe a rabbit, a purple rabbit, holding a sign that says Vultr. And what is actually going to happen is we are going to see on here, we are going to see the request coming up. That it's here, and we have this rabbit which is holding the sign Vultr. So that's just a traditional inference, and basically I have a script which does the same thing here. So we can look at it together, and actually it's like making a call on this like endpoint that we have here. And we can run a generation for once. So it's the same thing as we did like visually, but the difference is like it's a script, so it's generating a rabbit jumping in the air to catch a bird. So basically I can run it, and I'm going to get one image generated, and what we're going to do together is we are going to generate some load, and we'll see how it behaves, and I'm going to explain briefly what's happening behind the scene. So basically it generated like this rabbit, and now I can generate 50 requests, and we are going to see them appearing here. Up, we see that it's actually like coming up here, like the request, and we are going to see what we are technically doing behind the scene is we are observing like the traffic, and every 15 seconds we take a decision on whether we need to create more machines to support the workload. So behind the scene, like we see right now, a new instance was created because there is too many requests to properly deal with the traffic, and actually like more servers are coming up, which are going to serve and reply to this request. So that's the main principle, and it works across like one or multiple locations and across either CPU, GPUs, and accelerators. And it can run across any of Vultr's locations. And it can abstract the complexity so that you don't have to deal with the physical infrastructure. So, and what we looked at is like two key aspects. We looked at how we distribute like inference and agents with more efficiency. This works if you want to run like a simple model on a GPU, but you can also run thousands of containers for agentic workloads or for more traditional API. We have people doing it for traditional SaaS software too. And we have two key features then to help you basically adapt the infrastructure to demands. One is scale to zero. If there is no traffic, we are going to shut down all VMs and wake them on demand from the first request, and we are going to auto-scale horizontally depending on traffic. You can do this across like you can deploy a serverless container for all of this workload across the 32 global locations of Vultr in a few minutes. And that's it for me for today. So you can experience it on koyeb.com and get started with Vultr on Koyeb. We provide free credit if you want to experiment it. If you have any question, we have a small booth here today. I'm reachable here, and that's it for today. Thank you.